Okay, again, we're gonna go page by page. So if you wanna see me work something out or you need me to clarify something, now is your opportunity. So let's start with the first page. This was your polynomials. So you're adding, subtracting, multiplying, distributing, that kind of stuff. Any questions on these? So just to review, I know like this one had the, like I would say the special products will save you some time. So in like 39 and 40, obviously you can distribute that out. I could FOIL it out, expand and FOIL it out. Or like 3k minus 5m. Or I can use the shortcut on anything that's in parentheses squared. And that shortcut is take the first one and square it. So 3k squared would be 9k squared. Take the last one and square it. 5m squared would be 25m squared. And then double the product. So the product would be negative 15km. And then I double it. So it's minus 30km for my middle term. So stuff like that obviously help you save some time on this test. Again, as a reminder, there's 50 questions. So it's more than double a normal test, but you have like, you know, more than double that time, just around that. But you want to be able to save time on things like that. Questions on the first page? Going once, going twice. Okay, page 2. Now we're factoring completely. And again, factoring is built in a couple different ways in the test. Obviously, it's like these where it's just straightforward factoring. But then it also will happen in your adding, subtracting, multiplying, and dividing fractional or rational expressions. So you see it a lot. Questions on any of these? All right, 56, 8y to the third, minus 1,000z to the sixth. So this is a perfect cube. I would say 1,000 is higher than you would see. So if you wanted, I would just make sure you know your perfect cubes up to like 125. But this is the difference in perfect cubes. So this is that SOAP method. I'm going to cube root the first one and I get 2y. I'm going to cube root the second one and I get 10z squared. So when we cube root the exponent, we divide by 3 because it would be z squared and then z squared and then z squared. And then the first set of parentheses, you just use those two. I'm going to come back and fill in the signs. The second set of parentheses, I square the first term. So 2y squared would be 4y squared. Yep.
What did you do just?
The first term, that one?
Yeah.
You square it. So you square the first term.
Why do you square it?
That's how you factor perfect cubes. Like it's the method to factoring perfect cubes. Yeah. So you cube root and those two both go in the first parentheses, but then to start the second parentheses, you take the cube root of that first term, which is 2y, square it. The middle term is the product of the two cube roots. So 2y times 10x or 10z squared would be 20yz squared. And then the last term comes from taking the last cube and squaring it. So 10z squared squared is 100z to the fourth. And then our signs are SOAP. Same as the original, which is the minus. Opposite, which is plus. And always positive. So that's your perfect cube. $53. So the first thing I would look for is my greatest common factor, right? They're all divisible by 6. Is that the highest? 6 would go on the outside. And then they all have an A. The highest or the lowest exponent on the a is a to the 6th. So I can take that out of each of them. So I'm going to divide this by 6a to the 6th, this by 6a to the 6th, and this by 6a to the 6th. So each one. 48 divided by 6 is 8. A to the 8th and a to the 6th would be a squared. Minus 6 goes into 12 two times, 2. A to the 6th means there's one a left, and then the b is there. Minus 6 goes into 90 15 times. A to the 6th completely cancels out, and b to the 2nd is the last one. Good so far? Yeah, okay. Now I would either try trial and error with what's on the inside, or I would do factoring by grouping. So 8 times a negative 15 is negative 120. Factors of negative 120 that sum to negative 2 are negative 12 and positive 10. That 6a to the 6 is going to stay on the front, but now I'm going to replace that middle term with the negative 12 and the positive 10. So 8a squared minus 12, they both get an ab, plus 10ab minus 15b squared. And then I'm going to factor by grouping. So the 6a to the 6 still stays on the front. From the first set of parentheses, I could take out a 4a, and I get 2a minus 3b. From the second set of parentheses, I could take out a 5b, and I get 2a minus 3b. Now I take out what's the common factor, which is 2a minus 3b, and I group together what's left, 4a plus 5b. That whole thing is factored form. I think this is harder than any of the factoring questions that are actually on your test because it combines more than one thing. It's good practice because it combines more than one thing, but I think this is harder. You might get two, like you have to factor out a greatest common factor, but then it's probably not one with like an A and a B and that. So if you're thinking that, wow, that sucked, it's okay. What was the other one you asked? 55. Okay, so this one is the difference two squares. I would look at the numbers in the front, like 49 and 9 are both perfect squares, and then if the exponents are even, those are also perfect squares. So this is the difference of two squares. Factor the 49m to the 8th, you would divide it by 2. So it's 7m to the 4th, 7m to the 4th. And then square root the 9n squared, and it's 3n. And one gets a plus and one gets a minus. Chris. All right, so this time the greatest common factor is actually an expression. Well, there's two parts to it. 3 goes into both of these, so I can take out a 3. And then they both have a z minus 4. Technically, one has it twice and one has it 3 times. So you can actually take out a z minus 4 squared. So by taking out, we're dividing each of these by that. So 3 times z minus 4 squared and 3 times z minus 4 squared. That first term, 3 times z minus 4 squared, divided by 3 times z minus 4 squared is just 1. And the second term, 3 goes into 9 3 times. And there's 3, like a power of the exponent of 3 in the top, 2 in the bottom, which means I can cancel 2 of them out. There's still 1 left. So this would be plus 3 times z minus 4. Yep. Let me do this and then I'll go back to it, okay? Sophia.
Where does the 1 go?
I took this first term and divided it by the greatest common factor, and they ended up being the same thing. So 3 divided by 3 cancels out, and then z minus 4 to the second and z minus 4 to the second just becomes 1. Now I've got to distribute the 3 on the inside. So I have 3 on the front, z minus 4 squared, 1 plus 3z minus 12. And then I can combine those like terms in the last one. So 3z minus 4 squared, and then 3z minus 11. I also think that's harder than anything you're going to see on your midterm. Okay, so this is 64. And we have to keep change flip at some point. You can either factor first and keep change flip, or keep change flip from the beginning. I would only recommend the beginning so you don't forget to do it later. So if I were to keep change flip this before I factor it, I get 27m to the third minus n to the third over 3m minus n, and then times and flip the other side. And then you want to go in each spot, so each of those 4 spots, and see what can be factored. On the top left, those are actually perfect cubes. So this is the difference of perfect cubes, which is that SOAP method. To factor that, I would cube root the 27m to the third. I get 3m. I would cube root n, and I get n. And then the first parentheses is just those 2. I'll come back and fill in the signs. The second set of parentheses is the first one squared, so 3m squared would be 9m squared. The product of the 2, so 3mn. And then the square of the second one, square of the second one, which so n squared. And then your signs are SOAP, same as the original, opposite, and always positive. I would say for perfect cubes, you want to know up to like 125. So I would know, 1 cubed is 1, obviously. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. If you know those, you should be good. Then the bottom stays the same, 3m minus n, times the top right is the difference of 2 squares. So I'd square root the first term, 3m, square root the second term, which is n, and 1 gets a plus and 1 gets a minus. And then the bottom right is actually a perfect, we'd have to factor it out. So if I did, you could do it either first and last, or you could try to find the factors of 9 and n that multiply to give you that middle term. There are none. So when you go to factor this, it doesn't factor its prime, but if you look, it actually matches that top left one. So at 9m squared plus 3mn plus n squared, that whole thing cancels with this whole thing. And then the 3m minus n can either be canceled top to bottom here, or it could be canceled top right, bottom left. You just can't do it both times. So after you cancel those out, all that's left is the 3m minus n and the 3m plus n. Now, if I went to my answers and that answer wasn't there, but it was, if it was foiled out, make sure you can look for things like that. Most likely this would be left that way because you want it in simplest form. But if your answers don't match, look for things like that. Like if I foil that out, that's actually the difference of 2 squares again. Okay, and then 68. Now we're subtracting fractions. So we need the denominator to be the same. I start by factoring out. This would be x minus 3 and x minus 1. This would be x plus 1 and x minus 1. And then whatever's missing from the denominator is what I'm going to multiply the numerator by. So my least common denominator would be x minus 3, x minus 1, and x plus 1. So the first fraction is missing the x plus 1, and the second one is missing the x minus 3. So on the numerator, on the first one, I'm going to distribute this out. I'd get 3x plus 3. On the second one, this negative has to go with that too. So the negative 2 is getting distributed. I get negative 2x plus 6. And that's probably like this getting distributed to that negative 3 is probably one of the most common mistakes people make. Then this whole thing goes over the x minus 3, the x minus 1, and the x plus 1. And my last step is to combine my like terms. So 3x minus 2x is x, and 3 and 6 is 9. Any other questions from the top? So from adding, subtracting, multiplying, dividing. Okay, then came the rule of exponents. So this goes way back to the beginning, 7-1 to 7-9. Or 71, sorry, 71 to 79. Any questions there? Then came the radicals, so 89 to 91. Questions there? And dividing, so this is where we're rationalizing in 100 and 101. So I would say this is a question like I was kind of talking about before. If you get this answer, which is perfectly correct, if you get that answer, but then you go to your answer choices and you don't see it, then obviously it's a formatting thing. So like on WebAssign does sometimes, this actually took out the 6 from both of those. So just be prepared to like, if it's not there, don't panic. See if it's there in a different format. All right, questions on page, what are we on now? 3. At the top is the multiplying, adding, dividing, and subtracting of your, yep.
Can you do 68?
Sure. Okay, 67 doesn't have the same denominator, but these are opposites. So the way you do the shortcut for this is you keep the first one and change the sign on the second one's numerator. So like this is going to be my least common denominator, and that would be this times -1. But instead of going through the work of doing the bottom, I literally just have to change this by changing its sign. If there was two terms, if that was like 3 plus m in the top, then both would get multiplied by the -1. But really all it does is change the plus in between to a minus. So this becomes m minus 3m over and keep the first denominator, 4 minus m. And then m minus 3m is -2m over 4 minus m. So that's when they're opposites. You can just change the sign on the second one and keep the denominator from the first one. Sure. 78. Okay, so two choices here. One is move that whole thing to the bottom, making the exponent on the outside positive. Or the second, because there's a mix of signs, which is probably what I would have done, is distribute the -2 and then move what's still negative. So this -6 is going to get raised to the -2. The x squared is going to get raised to the -2. The y to the -3 is going to get raised to the -2. And the z squared is going to get raised to the -2. So start by distributing each of those exponents. -6 to the -2 means that 6 is going to be squared in the denominator, -6 actually, in the denominator. So this would be 1 over 6 squared, which becomes 36 in the denominator. X squared raised to the -2 would be x to the -4th. So that one also moves to the denominator. Negative y, why do I have negative there? Sorry, it's not negative. y to the negative third raised to the negative 2 would be y to the positive 6. So that one stays in the numerator. And then z to the second raised to the negative 2 becomes z to the negative fourth, and that moves to the denominator. And you said 79 too, right? Okay, so this time, anything that's got a negative exponent, I'm going to move first, and then I'll simplify after. So the negative 8 stays. The y to the 7th stays. The p to the negative 2nd brings down to the bottom, so p to the 2nd moves to the bottom. In the bottom, the y to the negative 4th is going to go to the top, and the p to the negative 3rd is going to go to the top. P to the 3rd at the top. And then you can combine the two y's, so negative 8y to the 11th. But the p's, if there's 2 in the bottom and 1 in the top, I'd cancel, so subtract that 2 or cancel out 2 of them, and you're left with just p in the numerator. Nope. Sophia.
And you can only do that if there was something plus p or something minus p and the other.
Correct. So if it said like, I don't know, like negative 8y to the 11th plus p to the 3rd over p to the 2nd, you cannot cancel part of it. It has to go into all the terms. So as soon as it's separated by a plus or minus, you can't simplify by canceling unless it goes into every single term.
So if it was plus p, it would probably be the two.
If it's, no, even then, it would have to be, like if this also had a p, then I can cancel out like one of the p's like that. But if it doesn't, if that 8 doesn't have a p on it, even if there's another p down here, you still can't cancel it because the 8 doesn't have it. Sure. Any other questions? So now we'll move it down to the radicals. So 89 to 101. Any questions on those? Sophia? 91. All right, so here we're gonna take our square root that's on the outside and distribute it in. So 3, you can write this as square root 3 times square root 3, just like that. And then we're going to come back and simplify that. Minus square root 3 times square root 27. The square root 3 times square root 3 cancels and just gives you 3, because any square root times itself would cancel out. So I just get 9. And then when you're multiplying square roots, this square root bar is technically just over both of those. So instead of multiplying it out, like I'd end up with 81 and then have to break it down again, you can actually just break it down from here. So 27 would be 3 and 9, which is 3 and 3. And then for each pair of 3s, one's coming to the outside. So that 3 comes out and a second 3 comes out. And I get 9 minus 81, or sorry, minus 9, which is 0. If you had multiplied the 27 and the 3, you would have gotten the square root of 81, which is also 9. Sophia.
Did you do 100 and 101?
Okay, so 100 has a fraction with a radical. You can't have a radical in the denominator. So we multiply by the opposite of that expression, 7 plus square root 3. So in the numerator, I'm going to distribute. This would be 14 plus 2 root 3. Yep.
What is it called when you multiply like with the plus instead of?
This is just rationalizing because this isn't the conjugate. Conjugate is the with the i's. So it's just, you're just multiplying by the opposite. And then in the denominator, you can use the shortcut, which is a squared minus b squared, or you can FOIL it out. If you use the shortcut, the a is 7, so 7 squared would be 49, minus the b is the square root of 3, and that squared would be 3, so this would be 46. Or you FOIL it out, 7 minus square root 3, 7 plus square root 3, and I would do first 49. Outer, positive 7 root 3. Inner, negative square root 3. Last, minus 3. Either way, you end up with 46 in the denominator. And then these are all divisible by 2. So I would take it one step further. 7 plus square root 3 over 23. 101 is similar, right? It says 6 over 3 minus square root 2. So you can't leave the square root in the denominator. We multiply by rationalizing. Or we rationalize by multiplying by the opposite. In the numerator, 6 times 3 is 18. 6 times 2, positive 6 root 2. Or 6 times root 2. In the denominator, shortcut would be 3 squared minus the square root of 2 squared. 9 minus 2, which is 7. And then that gets left just as it is because it can't be simplified. Yep. Answer, right? If that's the answer. Questions on any of these? The top is your, the top of page 5 we're on now, is your complex numbers. So 19 to 35 is dealing with the i's. Questions on those? God bless you. Then came the solving equations now that are quadratic. So some of these you were able to factor. Some of them you could use the even root property like 37. Some of them you had to FOIL first, get everything to one side, and then use the quadratic formula. So you want to be able to look because there's a big chunk of a section that literally just says solve. And you've got to be able to go back and forth between, can I solve by factoring? Can I use the even root? Or, God bless you, or do I have to use quadratic formula? Because those questions are all grouped together. And the directions just say solve like this. And those are a lot of open-ended questions, like just if you're preparing mentally. That's a lot of it. Some graphing and some like that. So when you're dealing with complex numbers and it's adding or subtracting, you just want to treat it as though it was a variable. So if it's addition, you literally just drop your parentheses, and I'd get 6 minus I plus 4 minus 2I, and then combine your like terms. So 6 plus 4 is 10, and negative I and negative 2I would be negative 3I. Unless there's an I squared in there, I just treat it like it's a variable. Okay, 27. Now you have multiplication and you also have something squared. So you have to take care of this first before you distribute. You can use the shortcut on it because it's an expression raised to the second power, or you can expand and FOIL it out. So if you expand and FOIL, I would multiply. 3 times 3 is 9. 3 times negative I times 3, and then negative I times negative I would be a positive I squared. That I squared becomes a negative 1. So I'd get 9 minus 1, which is 8, and then negative 3i, which is negative 6i. If you had done the shortcut on it, then you square root the first term, the first term, square the second term, double the product. So negative 3i times 2 would be negative 6i. And that I squared becomes a negative 1, and you still get 8 minus 6i. So if you do the shortcut, it looks like that, same answer. Yep.
So, negative I squared is always just I squared and then
No, I squared is -1. If it's negative I squared, it becomes +1 because it's minus a negative.
Wait, so positive I squared is always positive 1?
No,
I mean, negative I squared.
correct. Wait. I think you're saying two different things. I squared equals -1. So if it's negative I squared, it'd be negative times -1. That's +1.
Oh,
So it's a positive I squared. It's actually a -1. Yeah.
so if it were like, I'm sorry, if it were like -5 squared, would that be -25? Because,
Like this, without parentheses, is -25.
okay.
Yep, in parentheses is +25. Okay, but I didn't finish this question because we just did the squared part. Now there's still a -5i here. So when I distribute that in, I get -40i and then +30i squared. This I squared becomes -1 again. So I get -40i minus 30. And it will be put, like if it's open-ended, it doesn't matter about your order, but if it's in multiple choice, which I think these questions, I think most of the I's, well, not all of them, but some of the I's are in multiple choice, it will be written in standard form, which means the order will be reversed. Just don't be freaked out when it's not in the same order. And watch your signs when you rearrange it. Yep. Okay, so now you've got an I in the denominator, and it can't stay there because that's technically a square root. So this is when we multiply what's called the conjugate. You change the sign in between them. So 2 minus 5i gets multiplied in the numerator and the denominator. In the numerator, I would FOIL it out. 12 times 2 is 24. Then 12 times -5i would be -60i. Positive I and +2, +2i. And positive I and -5i would be -5i squared. Combine your like terms here, so 24 minus 58i. And the I squared becomes -1. -5 times -1 makes this actually a +5. So I end up with 29 minus 58i in my numerator. Plus 5 though. Yep, because that -5i squared becomes a +5. Then the denominator, you can FOIL it out, or the shortcut with i's is a squared plus b squared. It changes the sign in between, and we don't take the I. The B is just what's in front of the I. So this would be 2 squared plus 5 squared, or 4 plus 25, which is 29. And then when you go look at your answer choices, it's not going to be there because this can be simplified. 29 can go into itself once and to 58 twice. So it would be 1 minus 2i. Okay, so 35 has 1, a negative in the exponent. So I move it to the denominator. And then we went over the I rules yesterday. One is if it starts odd, it's going to be an I. If you divide by 2 afterwards and it stays odd, so I, 23 divided by 2 would be 11, stays I, now it's a negative, stays odd, sorry, now it's a negative I in the denominator. But if you don't remember that, because I assume most of you guys don't, then what I would do is separate off one of the i's so that it's even. Rewrite it as a power of 2. So I squared raised to the 11th times I. I squared is really -1, and -1 raised to an odd power like 11 means it's going to be negative. And then the I is still there. Yep. I'm not done yet though.
So I to the odd power is always negative, and then
After you divide by 2. Let me go through it this way and then I'll go back and do that. I'll talk about the shortcuts again. But I'm not finished because the I is still in the bottom and the I can't stay in the bottom. So we multiply by an I in both the numerator and the denominator. and I get I in the top. Negative I squared is the same thing as negative times negative 1, which is the same thing as positive 1. Yep.
How did it turn into negative I squared? How do you get the I at the top?
Whatever, so the I's in the bottom, you can't stay there, so you multiply by I. Like this is what my answer was at the ending point here, but you can't leave I in the bottom. So we rationalize by multiplying by I. So this was on the review packet day too, but the shortcut for I's, so once I move it to the bottom, because it's got to be in the bottom, like I-23 had to go to the bottom. But if it was just I to the 23rd, it's odd. If it starts odd, and then we divide by 2, and it stays odd, then it's a negative I. If after we divide by 2, it becomes even, then it's a positive I. So 23 means there's going to be an I in my answer. Divide it by 2, and it's 11 with a remainder of 1, but we're not worried about the remainder because that's the I. 11 is odd, so I know it's negative. If it started even, and then after we divided by 2, it's odd, it's a negative 1. If after we divide by 2, it's even, then it's a positive 1. And if you don't remember that, then you have to do it the way that we did it the first time. Sophia.
But how do you divide the odd number by 2?
It's always going to have a remainder, which is where the I comes from. We're talking about the whole part. So 23 divided by 2 is 11 with a remainder of 1. The remainder is your I. You don't worry about that. What's that? The whole part of that, right? When you're doing a mixed number, the whole part of that is 11, and that is odd, which means that I at the end is going to be negative.
What do you mean that the remainder is your I?
The one remaining, which will always happen if it starts odd, is why you have an I in your answer.
What was that when you did it without the shortcut?
So 25 is odd, right? Shortcut is it's odd, which means it has to have an I in it. You just eliminated 2 of your answer choices. Take the 25, divide it by 2. That's how many whole times? How many whole times does 2 go in? Say it again. Did you say it? I didn't hear you. 12. Is 12 even or odd? Even, which means it's going to be a positive I. That's the shortcut. If you don't get it or you don't remember it, then I have to take this. I pull off an I, which means I is always going to be there. It's always going to be part of my answer if it starts odd. Then I take the 24. I divide it by 2. So I rewrite it as a power of 2. I squared is negative 1. Negative 1 to an even power is positive 1. So my answer is just I. You're welcome. Yep. Other questions on this page? So actually we just did the complex. Now we're at the bottom, solving each equation. And this is a good chunk of your open-ended questions. Okay, there are a bunch in which the direction literally just say solve. And you've got to be able to identify if I'm going to be able to factor it, if I'm going to use the even root property, if I have to use the quadratic. That's all looped together, okay? So like something with 37, that's set up easy to do your even root property. Something like 39, I would see if I could factor it. Same thing with 41. When you get to 42, 43, and 46, you actually have to expand it first and then see if you can factor it. And none of those were factorable, which meant the quadratic came into play. There's quadratic with i's, like number 42, and then there's quadratic with real numbers like 43, 46. So just make sure, no, 43. 46 is, again, the complex number. So just make sure that you're prepared to kind of like ping pong back and forth between those different kinds. Yeah.
On the midterm, how many open-ended graphs are there?
Open-ended graphs, 2 or 3. I'm picturing 2 in my mind. Yeah.
How many points for like the open-ended questions? I think
Everything is 2 points apiece. So 35 questions, 2 points apiece makes up, so that's multiple choice, makes up 70 points from your test. And then the other 15 make up the other 30. But everything, so like obviously no partial credit on your multiple choice, but you get partial credit on those 30 points. Yeah. Worst thing you can do is leave this test blank. Because multiple choice, take an educated guess, open-ended, do some work because you can earn some partial credit. Yeah. Worst thing you can do is leave it blank.
How long do we have to take it?
You have the whole time. Like so when we come in, I think that block is like an hour and 45 minutes. By the time we take attendance, you get started. At minimum, it's like an hour and a half. Yeah. Any other question on this page? Yep. 42? Yeah. So the biggest mistake I would say people make on this one is splitting and solving that, but because it's not equal to 0, you can't do that. So I have to distribute this. I'd get 3x squared plus 2x equals -5, and then move the 5 to the other side. And then I would see if this is factorable. So if I multiply 3 times 5, I get positive 15. And if I go through my factors of positive 15, there are none that sum to a positive 2. If it was negative 15, I could do 3 and 5. But because it's a positive 15, they have to both have the same sign. It doesn't work. So then A equals 3, B equals 2, and C equals 5. And we have to do quadratic. I would definitely recommend quadratic over complete the square. That's your other option. So negative b plus and minus the square root of b squared minus 4 times a times c over 2 times a. Negative 2 plus and minus the square root of 4. This is 12 times 5, which is 60. So minus 60 over 6. I get negative 2 plus and minus the square root of negative 56 over 6. Immediately the I comes out. So it's negative 2 plus and minus I square root 56 over 6. But now I also have to see if I could break that 56 down. So this would be 2 and 28, 2 and 14, 2 and 7. And there's 2 2's, so one's going to go to the outside. And the 2 and the 7 get multiplied out underneath. So I get negative 2 plus and minus 2i root 14 over 6. And that can be simplified. 2 goes into each of those. So negative 1 plus and minus I root 14 over 3.
You can also write it like 2 root 14 with the I at the end, right?
Yeah.
Did you put it inside the bracket?
No, it's got to be outside. Yeah.
For open-ended, how do we know when we take the eyes out and when we just like, when it's no solution?
It will always say find, just solve. So you're going to always take the I out. Okay. Yeah. The only time you wouldn't is if you were graphing something, which won't be these. Yeah. So you'll include the I's in all those answers.
For these, if you're on the open-ended, can't you always do one bracket? Like if you get
Absolutely. Yep. I would just say factoring is faster. Even root, sometimes like 37, it's going to be faster to do even root on that. That would be the only benefit. But because as long as they're x squared, like if it was x to the third, now you got to factor. Yeah. So like I put the x to the third, the cube one is on the extra practice because that one wasn't on your review where you have to solve a cube one. You definitely want to practice that because that's quadratic and factoring.
Can you do it?
So like, try to give you a cube root that's not on your test. That's the hard part. Okay, let's say it's that. So the first thing you're allowed to do is not panic, right? This is like you take a deep breath because it's not going to be enjoyable. Maybe save this till the end, okay? But I know 64, I would know up to 125. So 1 cubed obviously is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. If you know those, at least you can identify that those are both perfect cubes. So I would look first at my variable. The fact that it's raised to the third is weird. These aren't, you can't like add the 25 divided by 64 and then cube root because you lose your imaginary answers. You have to factor this. So I cube root 64 x to the third, and I get 4x. I cube root 125, and I get 5. And then this is SOAP. First parentheses is just those two, and I'm going to come back and fill in the sign. Second parentheses, square the first one, so 4x squared is 16x squared. Multiply the two together to get the middle term, so 20x. And then square the second one, and that's the last one. And then our signs go same, opposite, always positive. So same being minus, opposite being plus, always positive being plus. Now we factored this kind of question already, but it stopped there because we were just factoring it. With this one, we now have to solve this. So I'm going to set this one equal to 0 and this one equal to 0. The first part, like even if you just got the first part, you get the points. So solve the first part. This is 5/4. That's one answer. The second part, you got to do quadratic on because it's not factorable. So I picked big numbers because I know they're not on your test, but like they probably won't be this big. But negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. And I get negative 20 plus and minus the square root of 400. This is 100 times 16, so 1600. Over 32. This is negative 20 plus and minus the square root of negative 1200 over 32. And that will always be an imaginary number. Like it's never going to be that second parentheses is never going to be factorable, and it's always going to be a negative, an I, because it won't show up on a graph. And then I would take out the I. I would break this down, so this would be 12 and 100. 100 comes out as 10, because I can square root it. 12 is 2 and 6, 2 and 3, so I can bring out a 2. And I get negative 20 plus and minus 20i. The only thing left is the 3 over 32. And then this becomes 10 goes in, or 2 goes in both of these, 10, 10, 16. Oh, 4 goes into it, sorry. 5, 5, and 8. Plus the 5/4. So really think about it. Like if you're running low on time and this question stresses you out to the max, maybe factor it, get the 5/4, and lose the 1 point on the other half, right? Like don't allow it to stress you out. If you have the time, you know how to do it. You know how to do quadratic. But if you're like freaking out, if you have a couple of left and one of them is this and you're running out of time, maybe just try to factor it, get the easy one, get your 1 point out of your 2. Yeah.
So you can't like cancel the 20s because they don't go into the 30s.
Correct. All right. Page 6. So at the top, we're doing all those other types of equations. So you had some where you factored, some where you had denominators, some where you had rational expressions or rational exponents, and then you got into your radicals, which was the crappy stuff. Questions on 63 to 81? Kylie.
Can we do a problem like 73?
73? Sure. Okay, so in 73, there's a square root on either side of the equal sign. I would say even if they were both on the same side, so let's say it said this, it could start out like that. And what you want to do is get it so that there are one on either side of the equal sign. So I would move that over. And then once you have it that way, there's only the square root on either side. So I can square both sides of the equation, and it actually eliminates my square root. And then you just have to solve it like it's an irregular equation. So minus 3x. And then add the 2. And the catch with these is you've got to check them by plugging it back in. So I would get the square root of 4 times 3 minus 2 equals the square root of 3 times 3 plus 1. And 12 minus 2 is square root 10. And 9 plus 1 is also square root 10. So it works. You want me to do the one where you have to like have more than one thing on there? Like 75?
Yeah,
Where they...
also, like, if you didn't check it, and, like, would this be, like, a multiple choice?
God bless you. This is a multiple choice one. I'm trying to picture it in my head. This is a multiple choice one. So what you could see is that 3 is there, but then you also might see no solution. I would say if 3 is there and no solution is not an option, you're golden. Circle it, you're done, move on. But if 3 is there and also no solution, then you got to check it. Or if you get 2 answers and one of the answers is a solution and then another solution is 2 answers, then you definitely got to check it. But yeah, this one is on that multiple choice section. All right, so 75 is x plus 2 equals 2 plus x. Or square root of x plus 2. So you want to isolate the square root, which it already is, and then square both sides of the equation. On the left, the square and the square root cancel. On the right, you can either expand and FOIL this 2 plus x times 2 plus x, or use that shortcut we just talked about. Square the first term, that's 4. Double the product, so 2x times 2 would be positive 4x. And then square the second one, and that's x squared. And then I see I have an x squared, so I'm going to have to get everything to one side. I get 0 equals, this would be 2 plus 2x, nope, sorry, plus 3x plus x squared. And I would put that in order because it's easier. X squared plus 3x plus 2. Then see if you can factor it. There are factors of 2 that sum to 3. Split and solve. And I get x equals negative 2 and x equals negative 1. And this time I would look at my answer choices. Are negative 2 and negative 1 a choice? But is also just one of those a choice? And is there one that says no solution? And then in that case, you definitely want to plug it back in to check it. So square root of negative 2 plus 2 equals 2 plus a negative 2 would be checking where x is negative 2. And then I have to plug in for negative 1. Square root negative 1 plus 2 equals 2 plus a negative 1. On the left, I get square root 0, which is 0 equals 0, so that one works. And on the right, I get square root 1 equals 1, and that one also works. So if my solutions obviously were that plus the other ones, I would circle that one because they both work.
And then are we going to do, like, partial credit on the multiple, on the very...
On the open-ended, yes. On the multiple choice, no. But on the open-ended, yes. Which is 30 points of your task. Like, it's 70-30. So everything's worth 2 points, but that means that 30% of, or 30 points of it can be partial credit. So I would say you just definitely don't want to leave anything blank. Like, that would be the biggest mistake you could make. Because 1, multiple choice, take an educated guess. 2, open-ended, at least earn yourself some partial credit. Okay, then the bottom of this was all your inequalities. This page is a lot of work, right? So all the inequalities, which is your test points. Questions on those, 83 to 95. Okay, so these, and again, it would be looped into that like, just solve. So because there's an x to the fourth and an x to the second, I can do first times last, okay? Or I can do trial and error, just making sure my first terms are x squareds instead of x's. If you do first times last, I get 4 times negative 1. Factors of negative 4 that sum to positive 3 are 4 and negative 1. And then replace your middle term with those, but both of them are going to get an x squared instead of just an x this time. Then factor by grouping. From the first set of parentheses, you can take out a 4 and an x squared. And I get x squared plus 1. From the second set of parentheses, you can take out a negative 1, and I get x squared plus 1. So my greatest common factor is x squared plus 1, and the 4x squared and the minus 1 get grouped together. I can factor that 4x squared further, or I can use the even root property. It doesn't matter, but I can't factor x squared plus 1 any further because there's no such thing as the sum of perfect squares. The difference, however, I square root the 4x squared and the 1 gets a plus, 1 gets a minus. And now we split and solve. So on the left one, when I subtract the 1, I get x squared equals negative 1. I have to do plus and minus the square root of negative 1, which is plus and minus I. So those answers will still be part of my solutions because it's not just all the real answers, it's all the answers. And then you'd get negative 1/2 and positive 1/2. So you have 4 answers here, negative 1/2, positive 1/2, negative I, and positive I. Yeah. Nope, and if you wanted to put plus and minus, if it's on open-ended, you can list it as plus and minus. Yeah. All right, so first thing is if you see your irrational exponents, this is when you're gonna be able to substitute, but I would want everything to the same side first. So I'd get 2x plus 3 to the 2/3 plus 2x plus 3 to the 1/3 minus 6 equals 0. Because I'm gonna substitute and then end up factoring. Remember, if the first term is the second one squared, then you can simplify by using, like we used a. We're going to say a equals whatever's the second one. So 2x plus 3 to the 1/3. So then my first term is that squared, so it would be a squared. The second term is just a minus 6 equals 0. Then I'm going to factor. So factors of negative 6 that sum to positive 1 are positive 3 and negative 2. Split and solve. A equals negative 3 and a equals positive 2. But I'm not solving for a, I'm solving for x, so I have to plug it back in to what I, set it back equal to what I substituted in for a. So negative 3 would equal 2x plus 3 to the 1/3, and positive 2 would equal 2x plus 3 to the 1/3. So I'm going to cube both sides of these equations. Negative 27 would equal 2x plus 3. Subtract the 3. And divide by 2. So that's negative 15. And then do the same thing here. Cube both sides. Subtract the 3. Divide by 2. This is, so I get negative 15 and positive 5/2.
Do you think we should go back and then look at all of our notes or just all of these different things?
I feel like if you can focus on the review and the extra review, you should be good. I would say if you got to something you didn't know how to do, that's when I want to go back to my notes and look it over. But there's going to be way more in the notes than there is. And we tried to narrow it down a little bit. Yeah, Sophia.
Maybe 77.
77. Did I do this one yet? No, okay. All right, so if there was just one square root on either side of the equal sign, I would square it. But when you've got a square root mixed in with a constant like this one is, you have to separate the square roots and then square both sides. This is the one where we end up having to square root twice. So I'm going to move this one over here. I get the square root of x plus 3 equals 1 plus square root 3x plus 10. And then square both sides. So square and square root are going to cancel on the left. On the right, this is where your shortcut comes into play. Either have to expand and FOIL that or use your shortcut of the squares, which is square the first term, square the second term, so I just take what's underneath, and then the middle is double the product. So 1 times that would be just square root of 3x plus 10, times 2 would be 2 square root 3x plus 10. And then the sign comes from here, so it's positive, and this would be always positive because it's squared. Now I'm going to combine my like terms. So positive 1 and positive 10 is 11. And then there's a plus 3x plus 2 times the square root of 3x plus 10. And then I got to isolate the square root again. So I'm going to subtract the 11 and the 3x. And I get negative 2x minus 8 equals 2 times the square root of 3x plus 10. Divide both sides by 2. And I get negative x minus 4 equals square root of 3x plus 10. And then we square again. Square both sides of the equation. On the left, I can use the shortcut again. Square the first term. Square the second term, double the product. So product this time would be 4x times 2 is positive 8x. On the right, the square root goes away. Subtract the 3x. Subtract the 10. And then we're looking for factors of 6 that sum to 5. That's positive 2 and positive 3. We split and solve. And we get our 2 answers. And then because this started with a square root, they have to be checked. So my advice is go look at your answers. If negative 2, negative 3 are there, and then there's also a no solution, obviously you want to check. If negative 2 and negative 3 are there, but also there's just a negative 2, there's negative a 3, now you need to check. If negative 2 and negative 3 are there, and there's not another option that like would be if one canceled or if both canceled, then you don't have to check. But obviously this is where you've got to plug back in. So I'm going to plug them back in up here. So I get square root of 1 minus, this would be negative 6 plus 10. That's 4. 1 minus 2 is negative 1. And that doesn't work. So that one's going to get ruled out. And then I would do the same thing with the 3. And I get 0 minus 1 again. And that's negative 1. And that doesn't work. So this would be a no solution one. Sophia.
So you always have to check the equations
When they start with square roots. Yeah. And I would say if this was, I think this is on the multiple choice part, but if it was open-ended, I'm not stressed out about checking it because we'll give partial credit. But if it was obviously on the multiple choice part, you definitely got to check your answers. Then came inequalities with absolute value, so 117 to 124. Kylie.
How did you know if the graphs would go out or in? Because wouldn't you plug in 0 for it? Wouldn't you plug
So there's 2 ways to do them. So I'm just going to pick 118. Unless there's one in specific you want me to do.
No, 118.
Okay. So there's 2 ways to do it. One is to know your and or trick with absolute values. And that is if the absolute value is isolated like this one and not a statement is read as great or, right? Or great or then I'm going to split this into an or statement. I change this sign. I put negative 2 on the other side. I keep this sign going in the same direction. So it's greater than, and then I write out what's in here. 5x minus 8. And then I put the word or. 5x minus 8 is greater than or equal to 2. Finish out your original one. And then solve these. And you get 6 is greater than or equal to 5x divided by 5. 6 fits is greater than or equal to x. But put that in order so it makes sense so the x comes first. The small side still is still towards the x. So like that, the big the alligator's eating the 6/5, right? So I still want that sign to go the same direction. And then solve what's on the right, add the 8, 5x.
Catherine Q, please report to student services. Catherine Q to student services.
And I know it's a less than 6/5 or greater than 2 or equal to 2. So I know that the bracket points out like that. So that's one way to figure it out, which is negative infinity to 6/5, 2 to positive infinity. The other way is to simply solve it as though it's an equals absolute value, which means I set 5x minus 8 equal to negative 2 and 5x minus 8 equal to positive 2. I still get the same two answers, 6/5 and 2. But then those you'd have to plot on your number line and test a point. So 0 would be to the left over here. If I plug in 0 to my original, I get the absolute value of 5 times 0 minus 8 is greater than or equal to 2. Absolute value of negative 8 greater than or equal to negative 2. And 8 is greater than or equal to negative 2. So I know to shade where the 0 came from, and it's in every other situation. So not here, but also here. So you can choose how you do that. Either remember the absolute value and or rule, which is if it's great or, it's or, less than is and, or set it equal, solve, and test a point. Okay, at the bottom came back the i's, so the complex numbers, expanding, and then the higher power ones. Sure. So the first thing is I would get rid of the exponents negative. So I put it in the denominator. So it would be I over, or 1 over I to the 27th. And then because it's odd, I split off one of the i's, and I know an I is going to be my answer. Then I take that 26 and make it I squared to the power of 13, just divide by 2, still times I, which means there are 13 negative ones. If there's an odd number of negatives, it's going to stay negative. But you can't leave the I in the bottom. So to rationalize it, I multiply it. And you can multiply it by positive I or negative I. It doesn't matter as long as you get rid of the I. So in the top comes back the I. In the bottom is negative I squared. I squared becomes negative 1. And negative 1 times negative 1 is positive 1. And I'm back with the I.
I tried doing that like a different way. Am I allowed to do it?
Like with your shortcut way?
Yeah. Like,
Yeah.
Okay.
Yeah.
Like what I did was like I wrote out a list of like all the different like.
Even odds.
Yeah.
Yeah, that's fine.
Okay.
Yeah. So if it's odd, right, because it's odd in the beginning, I know it's got an I.
Yeah.
If I divide the odd by 2 and it stays odd, it's a negative I.
Yeah.
You just got to remember that that's in the bottom, and then you got to,
Okay.
yeah, and then got to rationalize it. All right, 2 was, and again, on this one, remember it said in domain and range, but you'd also want to know how to do increasing and decreasing. So I think we did, I'll just write it on here, but I think we did it on the other day. This first section would be decreasing. So from negative infinity to negative 2 would be decreasing. Increasing would be from 2 to positive infinity on that one. And then for 22, this is increasing here. So increasing from negative infinity to 0. And then it's also increasing again from 0 to positive infinity. Because that point is solid, this, where'd it go? Oh, this one, I wrote on it. You can combine these into one because that whole thing, like this would technically be a bracket if it was range or domain. But it is actually increasing the entire graph because one has that solid dot. Kylie. The vertical line test. So like if I put a vertical line through here, the only time it intersects 2 points is here, but one of those points is open and one is solid. So this still passes your vertical line test. If they were both solid, it would not. It would fail your vertical line test.
So how was the first one? Yes.
Because there's no, like if I put vertical lines through here, it doesn't intersect any of those at more than one point. If it was like a parabola turned on its side, that's going to fail your vertical line test. And then remember, like I added onto the notes on the packet that you also want to know from points. So if I gave you 1, 2, 3, 4, 5, 6, is that a function? And it's a yes. But if I did 1, 2, 1, 4, 1, 6, actually I don't even need a third one, 2, 6. This is not a function because the x, that is 1, repeats with a different y. So you want to be able to determine it from a graph and also from a set of points. Okay, so for 20 and 22, it also says to find domain and range. So remember, domain goes left to right. If we're looking at this graph here, I have values for all of this. So the arrow would be from negative infinity up to this x value, which is -2, and it's solid, so it gets a bracket. Then it stops all these values, but starts up again here and points to the right, which means the domain would continue from +2 to positive infinity. Your range goes bottom to top. So lowest y on both of these is at 0. And then because the arrows point up, it would be to positive infinity. So that would be the domain and range for that one. For 22, your domain starts with the left arrow. It comes here with an open dot. So if that was the only section on it, it would be from negative infinity to 0, because that's the x with a parentheses. But because it picks back up here with a solid dot, we actually include that, and then the arrow points all the way to the right. So it is, instead of being 2 parts, because it continues all the way through, our arrows go from left to right. That would be all real numbers, or negative infinity to positive infinity. And then the range, the lowest y, even though this is all the way up here, this arrow continues to point left and down, which means it's always going to continue. It's never going to stop pointing down, which means it's pointing to negative infinity. And then this arrow is always pointing up, which means it would also be pointing, unending, and it points to positive infinity, which is why that's the range for 22. All right, page 9. So at the top, what you're dealing with your domain. Again, you want to make sure you know how to do that in interval notation. 34 to 37, you're finding the function value. Also, you want to know how to do that with a piecewise function, like the extra practice that I put on there yesterday. 38 through 47, you're graphing lines. 38 through 40, actually. 51 to 57, you're finding slope. 63 to 69, you're finding the equation of a line. And then 71, 73 on this one, where you're graphing using transformations. Make sure you'd also know how to find the domain on the range on this stuff. And it would be best to know how to do that without having to go fully graph. Like, know that if it goes up or down, which direction it would go, that kind of thing. So if I were to use this 71 as an example, my domain is all real numbers. My range goes from -3 to positive infinity. On 73, my domain again is all real numbers, and my range goes from negative infinity to positive 3. So just make sure you'd also know how to do domain and range. All right, 87 and 89 are symmetry. 93 to 95 is your description of transformation. So you'll get graphs where you're actually graphing it. You'll get a question on domain and range with transformations, and then you'll also get the describe it in words. Is it, over the x-axis? Is it shifted up? Is it shifted down? Is it shifted right? Is it shifted left? Yep.
Can you do one from like 89 or 87 and then one from 93 and
Sure. So here we'll do 87. So the test for symmetry, when it's not a function already, which is what's happening here, to test for x-axis symmetry, we do the negative y. So I'm going to change my y to negative y. And then because it's a negative squared, it goes back positive. So the rule is if it matches the original or every sign is different, then it passes that, which means this does have x-axis symmetry. To test for y-axis symmetry, I do the negative x. So I'm going to make my x negative x. There is no simplifying this. If I compare it to the original, it's not the same. The x is the only one that changes sign, and I need all three terms to change sign. So it does not have x-axis symmetry. And then the origin is both negative x and negative y. Negative x plus negative y squared equals 8. The x would stay negative, the y goes back positive, and 8 has no change. When you compare it to the original, it's not the same, and they're not all opposite, which means it's not the origin either, and it is just symmetric to the x-axis. And then you said the not 193, 94? Yeah. So, and again, you would want to know this based on the parent function x squared or square root x or absolute value of x. So like if I pick 95, let's say, the 2 on the front is a vertical stretch. Anything bigger than 1 is a stretch. Anything less than 1 is in between 0 and 1 is a shrink. So this is your vertical stretch. If there's something inside the function, either in the parentheses under the square root or inside the absolute value, it's going to be a horizontal shift, and it goes the opposite direction you think it normally does. So the -4 actually goes to the right 4. Let's say there was like a +3 at the end. That is a vertical shift up 3. The ones on the outside that are adding or subtracting are your vertical shifts, and they follow like normal. If it's plus, it goes up, and if it's minus, it goes down. Yeah.
Anything less than 1 is a stretch, you said?
It's a vertical shrink. So if that said 1/2 absolute value of x minus 2, let's say, this is a vertical shrink or compression.
And then anything above 1?
Yep. Yep. And you ignored the plus and minus sign. The plus and minus sign does your reflection. It has nothing to do with your vertical stretch or shrink.
And then would this be like a written one, or would this be
It's both. So there's going to be a question that says graph. There's going to be a question that says, here's a graph. Give me the equation. And there's going to be a question that says, describe it in transformation, and it's multiple choice.